Hello viewers, in today's session we are going to discuss an important problem from application of derivatives, and here in this class we are going to discuss this important problem related to increasing and decreasing functions. So here we have this problem in which we have to find the values or the range of k which belongs to the set of real numbers for which the function f of x is equal to k square mod of x minus mod of x minus 1, where x belongs to the interval, that is the open interval, minus 1 comma 0, is strictly increasing and strictly decreasing, right? So here we have a function f of x which comprises of two mod functions, mod of x and mod of x minus 1, and here x belongs to the interval minus 1 comma 0. It implies x is greater than minus 1 and less than 0. And here we have to find out the values of k for which this function f of x is strictly increasing and strictly decreasing. So we'll solve this problem with the help of the definition of absolute value function or the mod function, right? So let us first quickly revisit the definition of mod function. So now see, the mod of p is defined as positive p whenever p is greater than 0 or p is positive, and mod of p is 0 whenever p is equal to 0, and mod of p is the negative p when p is less than 0. So this definition is going to be very significant while solving this problem. So let us first redefine this function f of x by simplifying these two mod functions, mod of x and mod of x minus 1 in this interval, right? So let us first take a mod of x. Now see, mod of x is defined as positive x when x is greater than 0, and mod of x is 0 when x is equal to 0, and mod of x is negative x when x is less than 0. And similarly here we can define a mod of x minus 1, that is positive x minus 1 whenever x minus 1 is greater than 0 or x is greater than 1, right? And mod of x minus 1 is 0 whenever x minus 1 is equal to 0, which implies x is equal to 1, right? And here mod of x minus 1 is negative x minus 1 when x minus 1 is less than 0. So this is x less than 1, right? Okay, now let us see this interval, that is x lying between minus 1 and 0. Now see, here we have x less than 0 and here we have x less than 0. So mod of x is equal to a negative x when x lies between minus 1 and 0, because here mod of x is negative x when x is less than 0, and here we are given x less than 0. So we can replace mod of x by negative x. So we have k square and here we have minus x, and here mod of x minus 1 is negative x minus 1 when x is less than 1, right? So all the values of x which lies between minus 1 and 0 are obviously less than 1, right? So it is quite evident that all the values of x which belongs to this interval minus 1 to 0 are less than 1, right? So we can take mod of x minus 1 as a negative of x minus 1. So this is minus x and plus 1. So here we have for mod of x minus 1 minus x plus 1. So we can now write minus k square x, and here we have positive x, then here we have minus 1. So the uh, modified form of f of x after incorporating the definition of mod function, the function is equal to minus k square x plus x minus 1. So now let us differentiate this function f of x. So f prime of x is now given by d by dx of minus k square x plus x minus 1. So we have minus k square, derivative of x is 1, derivative of x is 1, derivative of 1 is 0. So f prime of x is equal to a minus k square plus 1, and from this expression we can easily conclude that the derivative depends on the value of k. So now with the help of the derivative of f of x, we can find out the values of k or the range of k for which this function f of x is strictly increasing and strictly decreasing. Now see, if we have a function say y is equal to f of x, which is defined in some domain, and this function f of x is said to be strictly increasing whenever the derivative f prime of x is positive or greater than 0, and this function is said to be decreasing when f prime of x is less than 0, right? So in this case, that is the case of strictly increasing, the slope must be positive or greater than 0, and here the slope must be negative or less than 0. So now in the case of strictly increasing, the derivative must be positive. So we have minus k square plus 1 is greater than 0. So substituting the value of f prime of x in this inequality, we have minus k square plus 1 greater than 0. Now we can solve this inequality. So we have minus k square greater than minus 1, multiplying both sides by negative 1. We can now write k square less than 1, because the direction of the inequality get reversed when we multiply both sides of the inequality by a negative number. So here we have k square less than 1, and this can also be written as k square less than 1 square, right? Because 1 is equal to 1 square. Now to solve this inequality, we can make use of a standard result, and the result says that see, if we have k square less than a square, then the value of k, it lies between minus a and positive a. And here if we compare this inequality with this one, then the value of a is 1, right? So k square less than 1 gives us k lying between minus 1 and plus 1, right? So when k belongs to this interval, that is minus 1 to positive 1, then the function f of x is strictly increasing. So now in the case of strictly decreasing, we have f prime of x less than 0. So we can now substitute f prime of x is equal to minus k square plus 1 less than 0. So here we can now easily write minus k square less than minus 1. Again, multiplying both sides by negative 1, we have k square greater than 1. So again, the direction of the inequality, it gets changed. So we have k square greater than 1, which can also be written as k square greater than 1 square. Now to solve this inequality, here we had k square less than 1 square or 1. Here we have k square greater than 1 or 1 square. So here again we'll make use of Another standard result from inequalities, if we have k square greater than a square, then k belongs to the interval that is minus infinity to negative a, union, and here we have positive a to plus infinity, right? So here if we compare this inequality with this one, then a is 1. So the solution of this inequality is k belonging to the interval that is minus infinity to minus 1 union, and here we have plus 1 to plus infinity. So this is the required interval in which this function f of x is strictly decreasing. So now we conclude that the function f of x is strictly increasing when k belongs to this interval that is from minus 1 to positive 1, and the function f of x is strictly decreasing when the value of k, it belongs to this interval that is minus infinity to minus 1 union 1 to infinity. So this is how, by the application of mod function and the definition of strictly increasing and strictly decreasing function, we can easily solve these kind of problems.